2.2, problem 39. I got to tell you guys, calculus and pre-calculus textbook authors are absolutely in love with this function right here. It's called the greatest integer function, sometimes called a floor function as well. And to be honest with you guys, it is not super important in the pantheon of mathematical functions out there, but it is kind of a cool function for this type of limit problem because it really does test if you understand what a limit is actually asking you. So there's three questions they're asking you here in 39, an A and a B and a C. We can't deal with any of those until we get a better sense for what this function is actually asking you to do. Now, translated verbally, what this symbol means, and by the way, I've seen it also written in textbooks this way, f of x equals kind of like a double absolute value sign, something like that. So kind of the same thing. Here's what it tells you to do. Whatever your input value is for x, you're going to go with the greatest integer that is not greater than the number that you were given. Whoa, that's confusing, okay? The greatest integer not greater than what you were given. So if I were going to ask you guys to do that floor function here, looks like an LOL, for 0, the answer is, what is the greatest integer that's not bigger than 0? Well, there's a lot of integers bigger than 0, 7, 2, 1, for example. But the greatest integer that's not greater than 0 is 0. So when you put a 0 into this function, you get 0 back out. Now what happens when you put in a 1? What's the biggest integer not bigger than 1? Not 3, not 2. Those are both bigger, but it's 1. So you get the point 1, 1. And I think you guys see where this is going for a while. Anytime you put in an integer, you get out the exact same integer again. So there's 2, 2. There's 3, 3, and this even works for negative numbers. The greatest integer that's not bigger than -1 is -1. So that's what this function looks like so far, and this looks incredibly boring. This looks like a linear function that you would just draw the line through and get y equals x. But this function isn't actually interesting until we start putting in non-integer values. So take a look at what happens when I ask you guys to do this floor function on 0.1. Now, first of all, I need an integer for my output here. Integers are whole numbers and their opposites, no fractions or decimals. So you're going to want to ask yourself, okay, 0.1 is between what two integers? Well, it's between 0 and 1. One of those two numbers is your answer. But one of those numbers, 0 or 1, is greater than the input value of 0.1. 1 is too big. So what we want is the greatest integer that is not greater than 0.1. That's 0. So when you put in a 0.1, you get out 0 again. And the same exact thing, the same exact thing is going to happen when you put in, for example, 0.5. You round it down and you get 0 again. The same thing would happen if you put in 0.9. You round down and you get 0 again. So this function kind of flatlines here, guys, until you make an open dot right here at the actual 0.10, and that's when it jumps up now to the 0.11. What's going to happen when you put in 1.1 or 1.2 or 1.3? It rounds down to 1 and stays there until we hit an open dot at 2.1, and then it jumps up to 2.2. Everything between 2 and 3 rounds down to 2 until you hit an open dot here. All right, and now we start to see the pattern right here. That's why this is sometimes also called a step function. And going back to -1, -1, the same thing happens right there. And this pattern repeats forever, guys. I'm only drawing, 5 iterations of it here so far, but I think you get the gist. It's just a big staircase. So now that we've got a sense of what this function looks like, I want to answer these three questions here, although I want to do them out of order. I want to start with C, which I think is the easiest one. The limit as x approaches 2.6, so 1, 2, 2.6 would be right about here, guys, and the limit as x approaches 2.6 on this step function. Well, let's take a look here, guys. If I go, I'll move this in just a second, but my big fat floating dot again, and if I were to move that on this function now to the left of 2.6 and start moving it closer to it, what is my y value approaching? My y value is 2, 2, 2, 2. Sounds like we're approaching 2. And from the right side, as I move x closer and closer to 2.6 from the right, my y values are 2, 2, 2, 2, 2. Hey, I think I've answered my question. We seem to be approaching 2 from both sides. That limit there, as x approaches 2.6 of the step function, is 2. We're converging on the same number from both directions. Now that's a two-sided limit, everybody, because the left and the right-hand limits agree with one another. But now we have two problems here with A and B. First of all, each one of those is only what we call a one-sided limit. And what I know probably bothers you guys more, they didn't give you a finite constant value like 2.6. They gave you an arbitrary constant like c. And I don't think, let me go back and check the problem here again, I don't think they told you what c was here, did they? Oh, it does say calculate c for an integer. Okay, that's important right there, so I should probably write that down. C has to be an integer. No fractions, no decimals. C is an integer. So what happens as x approaches c from the left? That's how we read that. So let me go back and move my magical dot here, and let's just pretend that our c value now is going to be 2, okay? We all do better with concrete rather than abstract. So what happens here, guys? As I move this red dot to the left of 2, okay, my y value here is 1. And then as I move it closer to an x value of 2, my y value stays 1, 1, 1, 1, 1. So my limit as x is approaching 2 from the left appears to be 1. Now if I moved everything around and said, okay, now I'm going to approach 3 from the left, now this limit looks like it's going to be 2. If I was doing 4 from the left, it looks like that limit is going to be 3. So whatever c is, everybody, it looks like our limit is always going to be 1 less than that, which is going to be the numerical expression c minus 1. Now, same type of problem here, but let's think about what happens when we're approaching c this time from the right. So if I were to let c equal 1, and I'll move my red dot right here, what's my y value? 1. And as I keep moving closer to an x value of 1, my y value is 1, 1, 1, 1, 1. It stays 1. What if c were 2, and I were approaching 2 from the right? My y values are all 2. If c were 3, and I were approaching from the right, my y values are all 3. So if we're just dealing with a value of c in general, it looks like that limit is going to be the value of c itself. So that's a tricky problem right there for a couple of reasons. First, we had to understand what the greatest integer or the step function, what it actually means. We had to know what its graph looked like, and then we had to understand some things about left-hand limits, right-hand limits, and two-sided limits, since there's no plus or minus after that 2.6, and we had to play around with the arbitrary constant of c, and recognizing then that the value of c would impact the value of our answers, our limits, for parts A and B. So a tough question all around.